Alright guys, today's goal, the learner will understand how to use functions that involve the irrational number e, simplify the expression. Okay, so we're going to treat this just like a variable, but it is a natural, it is an irrational number. Like e is like pi, it's approximately 2.714 blah blah blah. But we're not going to calculate that right now because that just requires a calculator. So what do we do? When you multiply the same base, what do you do with the exponents again? You add them. So this would be e to the 11th. And I'll show you, if you don't know where the e button is, we can find it and we'll learn how to use it on our calculators. So here I do 24 divided by 4 is 6. What do we do when we have division of the same base? What do you do with the exponents again? Subtract. So 8 minus 5 is 3. And it's always top minus the bottom. So let's look at one more. Okay, so now we have 10 to the third, 1,000. And then we have power to a power. So what do? You multiply. That would be e to the negative 12x. Now, if we want to make this positive, you would say 1,000 divided by e to the 12x, because remember, you move it down. Okay? All right, so let's take a look at what we're going to do with this irrational number e now. Okay, natural base functions. A function of the form y equals a times e to the rx is called a natural base exponential function. If a is greater than 0 and r is greater than 0, the function is an exponential growth function. If a is greater than 0 and r is less than 0, the function is an exponential decay function. So notice both have a being greater than 0, so this initial value always has to be greater than 0. It depends on the r. If r is positive, it's growth. If r is negative, it is decay. The graphs of the basic functions y equals e to the x and y equals e to the negative x are shown below. See how this looks just like the exponential growth we've been going over? And same here with decay. Because this negative, what it does is it reflects this over the y-axis. Okay? So, we're going to look at this problem. It says graph the function, state the domain and range. Okay. So what we have to think about here, the graphing piece, we're going to use our calculators to do. But the domain and range you need to start thinking about, because it's possible you could see like a no calculator question or just thoughts here. So we look at the equation. We have negative 0.75. So I know it's decay because of the negative. I know it's been shifted right 2 and up 1. Well, the standard domain and range, domain, all real numbers, range for standard function is all real numbers when y is greater than or equal to 0. Okay? Well, if we moved it up 1 unit, domain still doesn't change. It's all real numbers. But the range is moved up 1, so it's all real numbers when y is greater than 1. And I need to correct something. Is that greater than or equal to 0? It's y is greater than 0 because it never equals 0. That's y is greater than 1. Okay? And then what you would do is type this into your calculator, and again, we'll go over graphs in class if we're unsure, but this is what you would get. See how we have the original function? See how it moved? Right 2, up 1, right 2, up 1. Okay? The domain is all real numbers. The range is y is greater than 1. Okay? So let's take a look at some more problems. It says graph the function and state the domain and range. Okay, well, domain, that's the easy one every time. Negative infinity to positive infinity are all real numbers. The range, okay. The range, well, normally it's y is greater than 0, but we have this plus 1, so that means all real numbers when y is greater than 1. See, so what we have over here is, see how I have 1/2 times e to the negative x, and then there's the plus 1 still there. So what I did was enter that in the calculator, and I hit graph, and this is what we're going to get. See how it's shifted up 1, and when it's coming down here, it never gets below 1, and it never equals 1. So let's take a look at some more. Okay, continuously compound interest. So we talked about compound interest where it was this. It was A equals P1 plus R divided by N to the NT. The biggest difference here now is, you notice it says continuously. Okay, when interest is compounded continuously, the amount A in an account after T years is given by the formula A equals P times E to the RT. So when you think of continuously, you need to think of that shampoo brand called PERT, because that'll just help you remember this equation. Where P is the initial principal and R is the annual interest rate expressed as a decimal. So let's take a look at a few problems here. It says you deposit $2,500 in an account that earns 5% annual interest compounded continuously. Find the balance after the following years. Okay, so let's take a look. Problem said compounded continuously, so we need to use A equals the initial amount, $2,500, times E to the rate, which was 5%, but that's 0.05 as a decimal, times 2, because 2 years. So plug that into your calculator. Now, on your graphing calculators, you should hit second natural log, second LN button, and that's where your E button is. But you would get $2,762.93. Okay? So, let's look at the next example. 7.5 years. So it would be A equals $2,500 E to the 7.5 times 0.05. So calculate that. You get A equals $3,637.48. So be ready to use these equations and calculate E and things in class tomorrow. See you then.